Okay, math geniuses. So here is the video that was promised, and it will be absolutely fascinating and riveting. So let's continue where we left off this morning, and we can see here we have the integral of cosine 3x times the sine of 3x dx. And as I talked about before, and when we're doing U-substitution, it's helpful to figure out which one of these might be the derivative of the other. And that'll help us to figure out what u is. And as it turns out, these are kind of each the derivative of each other. The derivative of sine is cosine, the derivative of cosine is negative sine. So I'm going to say, so we don't have to deal with a negative sign, let's make u equal to sine of 3x. So let's do that right here. So we got u equals the sine of 3x. And that means du dx equals cosine of 3x times 3. And then solving for dx, we get dx equals du over 3 cosine 3x. And then we substitute all the stuff in there, and we get the integral of u times the cosine of 3x times, right here, du over 3 cosine 3x. Well, obviously the cosine 3x's cancel off, and the 1/3 goes to the outside. I'm going to save myself a little space, and I'm going to put the 1/3 right here. Integral of u du. Well, even a caveman can do this, or Owen. So that is going to equal 1/3 u squared over 2 plus c. And that's the same as, well, I'm going to back substitute right now. So u, what did we just say u was? U was sine of 3x. So u squared is 1/3 sine squared of 3x plus c. And we are done. And obviously, instead of writing 1/3, we could just write sine squared of 3x over 3. Also good. But there it is. There's our first integral. And the key here, again, is to figure out which one of these things looks like it's the derivative of the other. And in this case, it doesn't really matter. One is just as good as the other. Okay. So let's jump down here. And again, we're going to kind of ask ourselves, since we're trying to figure out what u is, it's pretty obvious what u is here because it's the inside function. And so we'll just stick with that. But again, thinking about u in terms of, well, if we're going to make u something, is the derivative of u somewhere present in the expression? Well, the derivative of 2x squared minus 7 is 4x. That's a 6x. It's kind of close. Things will cancel off, and we'll have some constant to put on the outside, and that's just fine. Okay, so let's go with it then. So u is going to be 2x squared minus 7. And du dx equals 4x. And then we'll just flip that around, and dx is the same as du over 4x. And then we substitute all the stuff in there. So now we have, and actually I'm going to bring this up while I'm at it. So we're going to have, this is equal to the integral of u, that's 2x squared minus 7, right? 2x squared minus 7, to the negative 1/5, because it's to the 1/5 power, and it's on the bottom, so it's negative 1/5. So I can use the power rule, of course. The 6x is still there, and we'll bring along the dx, and the dx is dx equals du over 4x. So we got du over 4x. The x's cancel. 6 over 4 is the same as 3 over 2. So it's going to equal 3 over 2 integral of u to the negative 1/5 du. And now we're going to add, of course, 5/5 to negative 1/5 and get 4/5. So that's going to be the same as 3 halves u to the 4/5 u to the 4/5 over 4/5. And then we will take the reciprocal of this, right? Dividing by 4/5, same as multiplying by 5/4. So that's going to get us, so 5/4 is going to be 15/8. So we got 15/8 u to the 4/5, but I know that u is the same as, where are we here? 2x squared minus 7. So I'm going to have 2x squared minus 7 to the 4/5 plus c. And there we are done with that. If we wanted to return this into the same format it was, which is a root format, then we could do the 5th root of 2x squared minus 7 to the 4th power, but this is fine. All right, those are our first two examples. Let's flip the page and jump to this next problem right here. So again, it's pretty obvious what u is going to be here. So u is obviously going to be the inner function, which is 8x to the 4th minus 12. But just checking here, if we find the derivative of 8x to the 4th minus 12, we're going to get 32x to the 3rd. There's an x to the 3rd right there. So this is a good choice for u, because if this is u, the derivative of u is in the integral somewhere. So that's going to ensure that things work out pretty well. All right, so let's rip through this. So we got u is 8x to the 4th, 8x to the 4th. And so therefore du dx equals 32x to the 3rd. And solving for dx, we get dx equals du over 32x cubed. 32x cubed. So just making the substitutions. So we got, this is going to be the same as the integral of u to the 1/2, so 8x to the 4th minus 12. That's what u is, right? Oops, it's 4th minus 12. Crap, I forgot the minus 12 part. It's all right. U is 8x to the 4th minus 12. Not that the minus 12 really matters all that much. And the derivative of that is still 32x cubed. So we're going to have u to the 1/2. So that's u to the 1/2 times x cubed. And then dx is the same as du over 32x cubed. So the x cubes go away, and the 1 over 32 goes to the outside. So we got 1 over 32 integral of u to the 1/2 du. So again, we're going to integrate this. So by adding 1, so this is going to be u to the 3/2 over 3/2. So we got 1 over 32 u to the 3/2 over 3/2 plus c. So again, we're going to multiply by the reciprocal, so that's going to be 2 over 3 times 1 over 32. Cancel the 2 and the 32 to make 16, so I got 1 over 48. So 1 over 48. And u is, where are we here? Right here. 8x to the 4th minus 12. So I got 8x to the 4th minus 12 to the 3/2 power plus c. And that is all I have to say about that. Okay, hopefully this is all going well. I mean, this one was pretty straightforward because the derivative just needed just a little tiny bit of constant action to get it sorted out. Okay, again, not so terribly different here. So it's going to be pretty self-evident, I think. U is going to be 3x plus 2. And so du dx is 3, and dx equals du over 3. Dx equals du over 3. So we're just going to make our substitutions here. And we're going to bring this up. So we're going to have, this is the integral. So instead of 3x plus 2 squared in the denominator, we're going to have u to the 2nd power, but negative, because we're going to put it into the top. So we're going to have u to the negative 2nd power. Our dx is du over 3. Kick the 1/3 out, and then integrate this. So I got 1/3 integral u to the negative 2 du. And when we integrate this, we're just going to add 1. So we're going to have 1/3 u to the -1 over -1 plus c. And we'll finish that up right over here. We're going to back substitute. That's 3x plus 2. So we're going to have 1/3. Well, let's make it -1/3, right? We'll take the negative, put it here. So that's the negative there. And then we got 3x plus 2 to the -1st power. But that's really just the same as 1 over 3x plus 2 in the denominator. And this, of course, is plus c. So then that's going to be equal to, let's clean this up here a little bit, -1 over 9x plus 6. 9x plus 6 plus c. And we are done. I mean, done with that problem. We're not done with the whole thing. Okay, let's flip it over. Oh, we already did that. Okay, so we got 5 more to go. 5 more examples. Okay, so here again, we're looking at an inner function and outer function. Pretty obvious here that the inner function is going to be x squared plus 10x. Oh, did I actually write in there? Crap, let me do that. And the derivative of that is going to be 2x plus 10. As we look over here, that's not quite 2x plus 10. We just need a 2. Some of you were like, I'm getting a little impatient with this whole U-substitution thing. Can I just kind of fudge this a little bit? Yeah, let's actually fudge it a little bit on this one, just because we've done a whole bunch, and so let's see if we can get away with this. So if this was 2x plus 10, then we could say, okay, well, we have a thing to a power and its derivative. Well, then all I need to do is just add 1 to this and divide by the new exponent, and I'm good to go. So let's do that. So in order to make x plus 5 into 2x plus 10, the derivative of this, I need to multiply it by 2. But as I said in class today and many other times, I can't just go around multiplying stuff by 2 and think that that's okay. I can multiply things by 1 because that doesn't change anything. So if I multiply by 2 on the inside and 1/2 on the outside, then I've really only multiplied by 1. So I'm going to do that. I'm going to say equals 1/2 integral of 2 times x plus 5 times x squared plus 10x to the -8 dx. Okay, so I have a thing to a power and its derivative, right? Because 2 times x plus 5 is 2x plus 10, which is the derivative of that. So I'm good to go now. So I'm going to integrate this bit right here as though it were just u. I'm going to keep the 1/2. So I go 1/2, and then we got parentheses x squared plus 10x. Add 1, so that's -7 over -7 plus c. And then we just need to multiply the 2 by the -7, and we're all set. So we got -1 over 14 times x squared plus 10x. Hopefully I don't run out of room here. To the -7th plus c. All done. All right, let's jump down right here. Same tricks, and I think we kind of got the idea here. And in fact, we don't even really need U-substitution here because this is just going to become the integral of x to the -1/2 dx, and we're good there. I'm glad this one's in here because I can talk about a point here. So just because I gave you a hammer doesn't mean that everything in the world is a nail. So just because we're talking about U-substitution, or you've learned about U-substitution, you don't have to use it with every problem. And this is an example of a problem in which we didn't even need it at all. So we could have just done this problem, and we're not going to because it's pretty easy. And so we don't need to use U-substitution every time, but we should use it when we need it. Okay, so let's jump over to here. And so here we're looking at, oops, I should put parentheses around here to make it a little more obvious what the inner function is here. So again, as we look at this, we see that x to the 4th is obviously an inner function. And let's just verify that it's even a good idea to make that into u. Well, the derivative of x to the 4th is 4x cubed. There's an x cubed. So we're pretty much on the way, and this is a good option, an opportunity for us to use U substitution here. So u is going to be x to the 4th du dx equals 4x cubed, and then dx equals du over 4x cubed. And I'm hoping that we're starting to be able to see how these things are going to work even before we start to do the U-substitution. So we're going to have cosecant squared, cosecant squared of u times x cubed, and then dx is the same as du over 4x cubed, over 4x cubed. The x cubes are outie, the 1/4 goes in front, so we have 1/4 integral of CSC squared of u du. And now we can ask ourselves, what is this the derivative of? Well, maybe it would be even nicer if I just threw in a negative sign here. Throw a negative sign here and a negative sign here. So now I can really ask, well, what is this the derivative of? So hopefully we remember that that's the derivative of cotangent of u. So now we're going to have negative 1/4 cotangent of u, but I'm going to save myself a writing step here. And we know that u is just x to the 4th, so this is going to be cotangent of x to the 4th plus c. And that one's done too. All right, 2 more to go, I think. Yep, 2 more to go. Okay, so it wouldn't be a day of calc without some trig. In fact, so we're going to end with our last 2 problems of being trig problems. This one looks like something might not be right here because, I don't know, if I look at 2 over x, where's the derivative of 2 over x? I just see this x squared thing on the bottom. Well, if we put these things in terms of negative exponents, it may be a little easier to see them. So let's rewrite this problem as the integral of the sine of 2x to the negative 1, and let's bring this up, times x to the negative 2 dx. So let's think about what the derivative of this thing here might be. So when we find the derivative of 2x to the negative 1, it's going to be negative 2x to the negative 2. Well, look, there's an x to the negative 2 right there. So while it at first appeared as though maybe there wasn't going to be a derivative for this thing if we call that u, then, then we were mistaken because there it is. So I'm gonna still use U-substitution here, only instead of calling u 2 over x, I'm going to call u 2x to the negative 1. So u equals 2x to the negative 1. So obviously du dx, as we just discussed, is equal to negative 2x to the negative 2. And dx is going to be du over that. So we're going to be able to write sine of u times x to the negative 2 times du over negative 2x to the negative 2. So obviously the x to the negative 2's cancel off. The negative 1/2 slips out onto the outside. So we have equals negative 1/2 integral of sine of u du. And all this just becomes so much cleaner right now. So what is sine of u the derivative of? Well, it's the derivative of negative cosine. And so then we can just put that negative sign along with that negative sign to make a positive. So we have equals 1/2 cosine of u. And what was u? U was, where did I put it? Right there. 2x to the negative 1. 2x to the negative 1 plus c. Or we could write 1/2 cosine of 2 over x plus c. And that's our first of 2 trig problems. And yeah, I don't need to make any other comment about that. Again, I think it's just, it's good to be careful with the negative signs here, right? Obviously, we needed a negative sign, so we So when we integrated here, we just stuck the negative sign onto that negative 1/2. All right, so last problem. All right, and again, I should be careful here with my parentheses. All right, so we have here, again, making sure that we're choosing the correct u here. You know, we might want to consider u to be 3x, and so maybe that will work out okay, but then we have this inner function here with a power of 4, and if we do the derivative, so let's back up here. I took off on a side road too quickly. So let's make believe we're going to say that, well, let's make u 3x. If we do the derivative of 3x, we just get 3, and, well, there's no 3 drifting around here, although we certainly could put one in, but that doesn't seem to really get us any closer to sorting this problem out. So 3x is an inner function, but so is 5 plus the sine of 3x, because that's to the 4th power. So I'm going to recommend that we make that into u. So again, always thinking about, well, if we choose u to be whatever it is we're choosing it to be, is the derivative of u somewhere in the problem? Well, the derivative of 5 plus sine of 3x is cosine of 3x times 3, but again, we know how to sort out the times when there's a missing constant. So let's do that. So let's say that u is equal to 5 plus sine of 3x. Yeah, that's all I have to say about that. And then du dx equals, derivative of 5 is obviously 0, so we're going to have cosine of 3x times 3. Stick 3 right there. And dx equals du over 3 cosine 3x. And now we can do all of our integrating. So we're going to substitute here. So 5 plus sine 3x, well, that's u. And so I'm going to say that that's u to the 4th, but it's on the bottom, so I'm going to say u to the negative 4th. And then we're going to have a du over 3, something went bad here. Oh, sine, cosine. That should be a cosine. Yep, I was just trying to copy this down and I wrote sine instead of cosine. Not smart. Du over 3 cosine 3x. So we're going to be able to cancel off the cosine 3x's, and we still have a 3. It's a 1/3 really, so we're going to kick that onto the outside. So we got 1/3 integral of u to the negative 4th du. And again, this whole bunch of gibberish here turns into this simple thing right here. And so then we're going to integrate that. So we're going to have 1/3. So we're going to add 1 to this. So that's going to be negative 3. So we're going to have u to the negative 3 over negative 3 plus c. So that's going to be equal to negative 1/9. U is, what did we say u was? That, 5 plus sine 3x. So we're going to have 5 plus sine 3x to the negative 3rd power plus c. And let's just return that into the format that it was given to us. So we'll write negative 1 over 9 times 5 plus sine of 3x to the 3rd power plus c. And there you go. Oops, didn't mean to run over the c there. Okay, so that's almost 25 minutes. And sorry to say, I'm going to give you another video to watch as well. So please make sure you take notes on that one. I'll put that on Classroom. Put both of these things on Classroom. And this is in lieu of staying after school. So instead of staying after school, we'll do some videos, I think. So there it is. Here's our lesson, well, the end of today's lesson. And I'm also going to put on another lesson to step us forward, and then we'll be able to work with that, both things on Wednesday class. So thanks for watching to the end. Please make sure you take notes on this and the other video that I'm going to send you as well. So a little extra work, as I said, at the end here, because we really need to get completed what we need to complete. So anyway, I'll see you guys tomorrow if you come in to chat about this, or I'll see you on Wednesday. Thanks. Have a good night.